right? Variability of data. Variability. Variability of data. Variability of data. We worked on weighted mean, and then we sorted out other problems of just one. I gave you one example of weighted mean. But today I want to look at the variability of data. Data on its own is nothing unless you interpret that data. But if you can just have numbers. Those numbers can be useless, can be nothing. So variability of data will depend on other measures of spread. I'll give you an example. I'll give you three data, and I want to see out of the three data, because where we will be leading to, what is called standard deviation and variance. But as it is now, let's start with these three data. One, assume this data A 7, 7, 7, 7, 7. And assume this data. The second data is, think of this data. 4, 6, 6.5, 4, 6, 6.5, 4, 6, 6.5, 7.2, 7.2, and lastly, which is the 11.3. 11.3. Second, the first one, second. Let's look at another one, the third one. And this third one is minus 1 and 5. Minus 195, 193. Minus 193. Minus 46. 69, and the 177. If you look at those data, you will notice that data number 1 is just the same. 7, 7, 7, 7. There are 7. There are 5 7s. 7, 7, 7. Otherwise, it's not making any sense at all. But if you look at this set data here, it's 4, 6, 6.5, 7.2, 11. There is at least much spread. If you look at that one, there is much spread. In other words, there are gaps. You can see that they are different. If you look at this one, the spread is a little bit high, because 1 minus 193 minus 46, 28, 69. So you can see that at least the spread is there. So out of this, whether the first one, the second one, and the third one, we can test them by finding range. Let's test them by finding range. Let's look at it. Range. Define range. How do you define range? By definition, range is the highest value minus the lowest value of data. The highest value minus the lowest value of data. That is range. Taka tutengeze madam moja, just the markers from where I test the office that you know the office now. All right, okay. You know where I stay? You don't know where I stay? The office. What is markers? Can you go get markers? Either get them from Frank. Frank should give you markers, Frank. So we are looking at range. Range as the highest value minus the lowest value. Let's look at range for the first one data, and then work out range for the second data, and work out range for the third data. If you look at the range for the first data, this implies you take the highest value, there is no highest value. So it is 7 minus 7, which gives you 0. Look at the highest value. But if you look at the range for the second one, the second data, range for the second data, take the highest value, 11.3 minus 4, which gives you 7. That is 7.3. Fine, thank you. Right? If you look at data for the third, the range for the third data, looking at data for the range for the third data, you are looking at the height 177 minus 193, which gives you 177 plus 193, and it gives you 0.73. So range for the first data, it is 0. Range for the second data, it is 7.3. Range for the third data, it is this one, 370. That's 370. So from what is there, you can easily notice that even we have got those ranges. Those ranges are just, they are giving us nothing. You look at that, they are just giving us nothing, and they are only based on a particular observation within that data. And if you look at that one, you can't. They are doing nothing unless maybe you do the percentiles or the other quantiles, maybe. But as it is, you can see that because this one is not spread, that's why you are having the range be 0. But because there is a spreading into this, that's why I have. So if you look at this one, range is telling us nothing. Because you can have something, you can have the highest value, the smallest. Range cannot define the characteristics of the data that you have. Therefore, it's better we look at another way of doing it. Then this is what is called standard deviation. So apart from looking at the way it is, we look at this one is 0. Look at this one is 7.3. It is giving us nothing. Because even if you look at this one, range is giving us nothing. You can have a number, biggest values, you can't define you are only taking the highest value and the smallest, but what about the other values that are there? You are taking highest value and lowest value, what about the other values that are there? That's what I'm saying. It is giving us nothing. So why can't we go for standard what? Deviation. It's better we go for standard deviation. Now, let's look at standard deviation. Standard deviation. So what's standard deviation? And variance. What's standard deviation? Standard deviation, you know what standard deviation is abbreviated as this. So standard deviation, short form for standard deviation is this. Yes? Or in other books is this one. That's standard deviation. Well, various, this is S squared, or this means various. In other words, what we are looking at there is this one, that standard deviation, you square the variance. That's what it means there. The standard deviation, you square the variance. So standard deviation, you square root the variance. Right. Let me define what is the standard deviation, and then we'll find the standard deviation for data 1, standard deviation for data 2, standard deviation for data 3. Then we'll go to another element. The word is standard deviation. To deviate, the rod can deviate. In other standard deviation, the way you deviate, standard deviation, how far are you from the mean? That's it. Mean is this one. That is mean. Remember, we had to use a formula to find mean, where we actually say the sum of x's divided by what? N. That's our mean. What we actually looked at last time. Now, if you look at this mean is the average. So the mean itself, how far are you from the mean? You can have a set of data, but how far are you from that mean? In other words, you are subtracting each and every element from the mean. You are getting standard deviation. Let's look at data 1, data 2, and data 3. Want to look at standard deviation. Let's look at these three data, and then we come up with the standard deviation. Before we come up with those data, let's write the following. Let's just write down the following tips that you can use when if you want to find standard deviation. Tips for standard deviation. That means, let's start it from there. Tips if you want to solve standard deviation. One. As I actually said already, I've said standard deviation is one of the measure, one of the element of measuring the spread of data. How spread is the data? That's standard deviation. But if you are to sort out this, the most important thing is, first of all, for each reading, suppose I've got my readings X. You have readings X. Assuming you have readings. You have readings X here. Right? You have all data, like you have all this data. For each reading X, calculate X minus X bar. For each reading X, calculate tip number 1. For each reading X, calculate X minus X bar. Calculate X minus X bar. You calculate that? In other words, it's a deviation from the mean. This means it's a deviation from the mean. It's a deviation from the mean. Let me tell them this guys, they should make noise. For each reading, calculate X minus X bar. That X minus X bar, that is you are deviating from the mean. In other words, mean is there. You have to deviate each and every element. Right? The second one, the second tip is square the deviation. Square the deviation to give tip number 2. Square the deviation to give X minus X bar squared. Square the deviation to give X minus X bar squared. Right. When you, for example, if you look at this one, if you are calculating X minus X bar as its deviation from the mean, like you have X here, you have got X minus X bar. You know X bar is average, right? You add all the numbers, but how many there are? It's this number here. Hey, X is this number, X is these numbers, right? But this one is the average. Average, you are adding all these numbers, divided by how many there are, right? So it's going to be here. For the first number, for the second one. So when you add this, all the numbers that are there, when you add them here, you will notice that they will give you a 0. Whatever the case, they will give you a 0. In other words, what you are doing here, you are here. You are deviating from the mean. To deviate from the mean is there. You are running away from the mean. You are running away from the mean. You are running away from the mean. Mean is there. So you are running away from the mean. It can be either positive numbers and negative numbers. That's what it means there. They will have positive numbers here and they will have negative numbers. And when you sum them, when you add them together here, you are going to get a 0. You will see from the example that I will give you. Another one is this one. You square the deviation to give this. Why do you square the deviation? Why do you have another one? Why do you square the deviation? Why do you square the deviation? You are squaring the deviation in order to run away from other negative numbers. Because here you have my negative numbers and you have the positive numbers. But now, because you have positive and negative numbers, to run away from that one, that's why you square the deviation. You are running away to get now a 0. Because the moment here you have a 0, but you have positive and negative numbers. And these negative numbers, we don't want negative numbers. That's how we square. When you square, you have fewer numbers. ordinary numbers. So that when you sum these numbers, that is what we want. How many row will be to sum up all the numbers? That's what we are looking at here. Tip number 3. Tip number 3. Find the sum of x minus x bar squared. The sum of all these values. Find the sum of. Find the sum of. Find the sum of x minus x bar. All values. In other words, what we are looking at here, this part here, you are getting that. You are having the sum of that. You are getting the sum here. Then after that, then find the average by dividing the sum by n, the number of readings. Whatever you have obtained there. Tip number 4. Tip number 4, you need to find the average by dividing by n. Find the average by dividing sum of x minus x bar squared by n. The answer you have obtained here, after you have summed everything here, you divide by how many there? You have added, find how many numbers are there, you divide by 5. And that answer you get from here, the moment you add and you divide by n, how many numbers are there? That is what is called variance. This is what is called variance. Variance is coming up here. Variance is coming here. Find the sum of x minus x bar squared for all values. Yes, for all values. On variance. Okay. When you have added everything here, whatever you have added here, you divide by n. How many numbers are there? What you are getting, that is variance or variance. Variance, you are adding everything from here, divide by how many numbers are there. What you are getting is variance. Then, the last step is now, finally you need to find the standard deviation. So, finally, you take opposite the square root of the variance to obtain standard deviation. What you do is, number 5, you square root the variance. You square root the variance to get standard deviation. You square root the variance to get standard deviation. You square root this one, you are going to square root that. In other words, what we are saying there is this. What we are saying there is we are running short of water. What we are saying from there, we square root this. What we are doing is standard deviation. Standard deviation from there is just sum of x minus x bar squared divided by n. The answer is square root of that. That's the standard deviation. Sum of x minus x bar squared divided by n, then this is the square root. Square root of that one. You have to do standard deviation. Here, you look at whatever you have obtained here, and then you square root of that one. In other words, square root of the variance. You square root of the variance, and this is the variance. The moment you square root of the variance, what you are getting is what is called standard deviation. Then, these are the tips for you to get the issue of standard deviation. Let's look at the five data that I gave you. Let's find standard deviation for the 5 data that I gave you. Let's look at that. We have agreed range giving us nothing. Let's go to standard deviation. Have anyone with a tissue? Tissue. If you are not understanding, tell me. If you are not getting it, tell me. Right? Are you getting it? That's good. Let's start with the standard deviation for the first one. Let's find standard deviation for the first one. And then we go to standard deviation for the third one. Then we'll go to the standard deviation for the last one. Now, if you look at for the first one, go to standard deviation for the first one. X is 7. 1, 2, 3, 4, 5. We need to find x bar. X bar is equal to sum of x divided by n. Average. That's what we are saying. You add all the numbers, which is the 35 divided by 1, 2, 3, 4, 5. 5. And the answer is 7. So you have added 7 plus 7 plus 7 plus 7 plus 7 divided by how many numbers are there? We are finding a mean. Hey, mean. You add this plus that plus that plus that plus this divided by 5. The answer is 7. Mean. Right? Now, this mean, this is your mean. So for the first one, x is 7. 7 minus mean is what? 7. For the second one, 7 minus 7 minus 7 minus 7 minus 7. What you are getting there is what? 0. Huh? That's what I'm saying. It's not making sense at all. You square the zeros. Again what? 0. You add the zeros. Again you are getting a 0. It's not making sense at all. There is no spread. In other words, the standard deviation is 0. Variance is 0. It is making it's senseless. You get what I'm saying? Yvonne, what have I said? Yvonne, what have I said there? You add this plus this plus this plus this plus that. Right? In other words, what do you do? 7 plus 7 plus 7 plus 7 plus 7, right? Divided by what? 5. That's why this one is what? 30 what? 5. Divided by 5. The answer is what? 7. The 7 is this one. Right? And this 7, it is this one. This one, it is this one. When you do is 7, it's going to be this big. That's why the data is said, there is no sense. There is no sense. No sense at all. Clear? Huh? Is it fine?
Yes.
Are you okay? Yeah? Right. Let's look at data number 2. Let's look at data number 2. Why is it that this data is used? Maybe it's senseless. It's just because there is no spread. The data is just the same. There is no spread. That's why the data is useless. This data is useless. There is no sense at all. Let's go to second data. Let's look at the second data. Data 2. X 4, 6, 6.5, 7.2, 11.3. X minus X bar. X minus X bar what? Square. Right? For this one, let's look at this. If you look at, we need to find the mean. Let's find mean. Let's find X bar. Mean, you add all the numbers, divide by how many there are. You sum up all the x's divided by n. Can you sum up these numbers and divide by n? How many numbers are there? Give me the answer. I shouldn't be a robot here. So add the numbers and divide by how many there? Huh? 7. In other words, alright, the X bar is 7. So this is 4 minus 7, right? 6 minus 7, 6.5 minus 7, 7.2 minus 7, 11.3 minus 7. Give me the answer here. For the first one, negative 3, right? The other one, negative 1. The other one, negative 0. What? 5. The other one,
0.2.
very good, 0.2. And the other one, 4.3. Can you sum? I want you to give me the sum here. Can you sum this? Can you sum? Find out the sum of this one. What are you getting here? add this. Can you add that also? In other words, what you are doing here, you are deviating from the mean. You are deviating from the mean. But that's why you have put negative numbers and have put positive numbers. That you are deviating from the mean. But now, if you look at that, can you sum up that, those numbers? Add them. Add them together. Phones have tend to be calculated.
It's 1.
Huh? I totally disagree.
0.
0. Do it again. -3, -1, -0.5. In other words, -3, -1, -0.5. It gives you -4.5. Right? And if you look at this one, 4.3 and 2, it gives you plus 4.5. When you subtract the 2, it gives you what? 0. Are you listening? Alright, take your calculator. You know this is minus and plus. You subtract the 2. It's the same as -1 plus 1 is 0. -1 plus 1, the answer is what? 0. Use your calculator, use your phone, and -4.5 plus 4.5. What is it giving you? Yvonne, what have you found?
0.
You are getting 0 here. That's what I was saying. The moment you are getting is 0, you need to come up with this column. So that you are running away from negative numbers, right? So this one is -3 is going to be 9. It's 3 squared, right? -3 times -3. You are having here square. Hey, you are having it -3 bracket squared. If you have to punch your calculators, use my brackets here, -3. And it is going to be very different. If you do -3 squared here, it's going to give you a different answer. It's going to give you a different answer. But use this.
What's the difference?
Use your calculator. Use your calculator. Brackets -3 bracket squared. And in -3 squared. Tell me what it is. Do it. Do it.